Alright, hello everyone. It's already January 21st. Alright, let's do this. Old question. Restore IP address. A valid IP address consists exactly 4 integers separated by single dots. Each integer is between 0 and 255, cannot have leading zeros. This are valid, but this, and this are invalid. Given a string containing only digits, return all possible valid IP addresses that can be formed by inserting dots into S. You are not allowed to reorder or remove any digits. You may return the valid addresses in any order. I need my pencil for this. So it's the same thing, right? You're given a value, and of course if it starts with 0, you only have one way to do. So you create the first one and then you say the remainder, right? How many is in the remainder, and then you'll go to the next one and see how many is in the remainder, and then go for the next one. So I can choose 2 by itself, right? In the first example I have 255 255 11135, and we can only go from 0 to 255. So we can say 2 and then give me 3, right? And we say 25, give me 3, 255, give me 3. And now we have 55 255 11135. Let's say give me 5, give me 3. And we say yeah, give me 3, right? And then eventually, you see it's impossible, so we can now go. So it's basically, we can do it like a backtracking kind of way. Yeah. Let's see if we can just code from scratch a backtracking solution. In DFS, what do we have? Index, right? And then we say the IP gonna be a list of str. I'm gonna have res equal to this. Don't return anything. And then and then num remain. Okay. So we say if remain is equal to 1. Well, actually no, we have to say if remain is equal to 1, and then we have to take the whole thing, right? And if so we take 1, we could be reaching, okay, we should be like this. N equals len s, right? If index is equal to n and rem, yeah, if this is equal to n, so already hit, but definitely we haven't reached this, and this is just return, it's just fail. If it's 1, then we need to see the remainder, right? And we say if n minus index, I want to see how many left. It's n minus 0, yeah. If n minus index is larger than 3, then we return, okay? If it's smaller than 3, elif, right, we say if n minus index is larger than, no, it's larger than 3, and I'll say it's larger than 1, and s index is equal to 0, that return. Otherwise, it's either smaller, it's equal to 1, right? Either it's not, so it's either smaller, larger than 1, and this, right? So we can do, or you know what, it will be actually, if this equal to 1, and this is equal to 0. No, I like this. If it's larger than 1 but more than 1 and leading 0, so that's no go. So the remaining is a go. So what we can go is just to add to IP. All right, we can add to the IP. So what we can do is whatever IP we have, we can do that, right? And then we add this to it. So we can say rest.append dot what we might be able to do is we're going to join IP, okay, and then plus dot plus s index towards the end, right? That's it. And return. Else we have more remain. Then we shall take one of them. All right, we'll take one of them, put into IP, and then we'll do, and then we'll pop it. We'll put 2, put in, and then we'll pop it. Yep. So we're gonna say depends, right? If it's, then we'll say if s index is equal to 0, the current is a 0, so then we have only one option, which is do 0. Then we have to say IP dot append 0 DFS index plus 1 rem minus 1 and IP. And once we're done, IP.pop. Okay. Else, if it starts as not a 0, then we can say for I in range 3. 0. Oh, it's not 3. It's this. Right by itself. Should be 1. No. Index to index plus I. So it will be 0, 1, 2. Yeah, because I can only go forward 2 times. So I say I in range 2. So 0, 1. No, it's 0, 1, 2. That's 3 of them. Then we say if index, if s I, no, index to index plus I plus 1, right? Because index plus 2, so plus 1 plus 2 is plus 1. If this is smaller or equal to 255, then we can say DFS index plus I plus 1, right? Index plus I plus 1, and rem minus 1, and IP. Oh, I haven't even done IP yet. Dot append. Say potential is this. So if potential is smaller than this, we'll then append potential, and then this will do IP. Once we're done, IP will pop. All right, and if it's larger, then we just keep going. But it only happens in the last one, so it doesn't really matter that much. So we go through this, and that's it, right? We go through this, and that's it. And then we can organize this. So the only time we can do this is if this is smaller or equal to 3, right? If it's smaller or equal to 3, and no, it has two situations. We can say if this is or this, right? This situation, or this situation. Now we return other three situations. That's good. Do this. It's fine. Okay, say elif. Yeah, with if, elif, and else. Okay, now we can do DFS. Start with 0. How many? I have 4. And start with this. I'll return res. Okay, let's give it a shot. Oh, I can play with this a little bit. S. Let me restore IP address. Okay, res.sort, answer.sort. Try this. Oh, we have trouble. We seriously have trouble. What the hell is this thing? 101, this, 2, 3, and then we go to the next one. Index equals n. Right? Hold up. I 2, 3. Yeah, I do 2, 3, and then I do this. Isn't this index equal to n? No. It is. Five. We have 2 and 2, 3. And 7. Isn't this 1, 2, 3, 4, 5, 6? How'd you get a 7? Oh, I see. This has to be minimum of n. There we go. I see the problem. Ah, larger. Then I don't have to worry about this. There we go. All right. Try. Ooh. Nothing and nothing. Okay. Become smaller. Ooh. That is not expected. I was just playing around. Didn't expect these two to be wrong. Holy crap. Man, these days are not fun for me. I rarely was able to solve everything from the start. I got nothing. What? That doesn't make any sense. How the hell are you gonna get anything? Take one, take two. Take one, take two. And then should take three. Why don't I take three? Well, we take one, we have one. Have three remaining. We do this, we have two remaining. So we take it next, we have one remaining. And when I have one remaining, it's too big. So we do this, so none of these work. Okay, that's actually true. So I take 1, 2, 3, that's also too big. So I take 1, 2. No, take 1, 2, 3. 1, 2, 3. Wait. Something is not right. We have two remaining. We have one remaining. I think I got it wrong. I think this should be 0, right? If rem equal to 0, if I have 0 remaining, then we need to check. I think. Huh? Wait, what happened? If this is larger than n, or just say if index, if this is larger to n and rem, if this, right, larger than 0, or rem, no, that's it. And then here, if we say if index is not equal to n, then we will return Otherwise, we'll do this. And now I can just do this. The hell? One, two, three. Yeah, let's keep tracking this. 1, 2, 3. Right? Okay. 1, 2, 3. Index is 3, so 0, 1, 2, 3. And then I'll take remaining is 2, so I can keep going. And it's not equal to 0. S index is not equal to 0. So for I in range 3, I have S index, so index to 1, but then just smaller, so IP dot append, and index plus I0 index plus 1, and the remaining minus 1. What? What? The hell? Right. What did I do wrong? Four remain, right? And then we add 1. Yeah, that's what we do here. Index 0, IP is 1, so I put the first one in. And then I do 0 plus 1, so I go to 1. So next one is 1, we have 3 remaining, okay? And then I'll take 2. So next I have 2 remaining, right? And then I take hold up. Index is already, when we call this index already 2. Index is 2 here. And remaining is 2. So index and remaining larger than 0. Now index is not larger or equal to n. And remaining is also not equal to 0. S index is not equal to 0. So I should fall here. So falling in range is 3. Pot should be 2 and 2 and 3. So pot should be 3. Oh, 3 does not smaller or equal to. I have to int this thing. I have to int this thing. Oh, otherwise I was like, why does it not work? I mean, the good part is it simplifies it actually. Or put as a 0 and simplifies it. If it's 0, then we only do 1. Otherwise, I mean, actually I can, no, it has to be, this is 0, then we only do 1. Else, we'll do all 3. I mean, we could just do 2, right? We could just do 2. How can we make it simpler? It's okay. It's okay. Let's make it. It is fine. Yeah, it is fine. (2019). Oh, backtracking, but I made a mistake that wasted me a long time. I forgot to turn the string into number before making comparison to 255. What's the runtime? What the hell is this? M to the n times n. Oh, that was iterative. Combinations. We can list all possible combinations. Ah, I see the iterative. Four strings means you need to put, oh, you can even combination it. Ah. Yeah, you have to check every single one, so you just find how many total possibilities there are. I mean, if we have length is n, and we have to drop it inside, so that's n minus 1 positions, right? We have n minus 1 positions, and we choose 3. as most m digits. Oh, it's n integers. And each integer is most m digits. I don't understand the time complexity. So 1 digits, we got a 1. 2 digits, we got another 1. 3 digits, so that's m. Right? And then inside here, so I see m to the n minus 1. Because every time you do 3 times. Okay. So m to the n minus 1. You take m times n. All right. But I have another solution I want to try. I will not call it that way though. I'm gonna use I'll use combinations. Okay. What I'm thinking is I have S, right? We have 1, 2, 3, 4, 5 positions. So n minus 1. And then we can say 0, just insert right after. So we have this. We choose 3, right? We choose 3 positions. So we get it, we just insert after. So we can say for combination in combinations, n is this, right? N minus 1, choose 3. And then we need to get all of them. So we're gonna sort it, right? And then for each say IP equals, and then for I in sorted combination, and p dot append s. Ooh, I need a previous. Okay, IP and pre is 0, so there's gonna be pre to I plus 1. Okay, and then we say if we do it separately. Def is valid, s is gonna be string, right? And I'm gonna do a boolean value here. If len s is larger than 3, return false. Okay. If len s, now if s0 is equal to 0 and len s is larger than 1, return false. Okay. Now we're gonna return int s is smaller or equal to 255. And now we can say if self dot is valid, IP minus 1. If not, right, then we'll break. Right, then we'll say else, only if everything works. And rest dot append dot join IP. And we'll return rest. Alright, let's try this one. Solution 2. Huh, can't do that, huh? Ooh, what the hell? What the hell? Yeah. Pre is 0. Oh, I forgot to do. Shoot. Pre shall equal to I plus 1. Because I is this, right? It was a 0 to I plus 1, so it should be I plus 1. Well, I only have 3. Doesn't make sense. The last one comes up. Oh, the last one comes up. I don't have another one. Damn. I need to put another one. Plus n. There we go. We have to have another one at the end. There we go. Use combinations to get all possible partitions. So it's combination now. N choose 3. Right, n choose 3. So n factorial, 3 factorial, n minus 3 factorial. Which is n. And choose m, right? Which is n to the m and divided by m factorial. And not really. Whatever it is, I don't care. I'm late today again. Late is the time. Whatever it is. Late is the time. Okay. I want to do this. Well, based on what we did yesterday, what needs to be done is to iterate everything. Okay, basically what it means for each situation, we need to put it inside, unless it's impossible. Okay, so the situation is going to be, for each one, we're not gonna do any comparison. So we just look into the previous one. When the loop through the previous one, put it into the current one. Man. So this has to be a list of lists. All different situations. And then that's the first one, the first one, the first one. Okay? So this is the first, is gonna be like this as well. Okay? And then option 1, we're just gonna append everything. Right? Unless it's, I mean, if it's impossible, we only need to, you can say for d1 st1, right? d1 st1 in temp j-1, right? If d1 is smaller than math.inf, then temp.append temp.append, no, j, so temp.append this, and temp-1.append d1 st1, right? So we go through all this. Option 2, for d2 st2 in dp j-1, right? If this is larger than 0, right, and d2 is smaller than math.inf, we do temp -1, so st equals st2, copy it, and this will dot append d2 plus, right? We have this. Wait, hold on. This and st. Okay, now st j-1 won't be minus equal 1. Right? So now we have 10. If otherwise, we don't even worry. 3. Same thing. 4. D3. ST3 in DP J. Okay. Now we don't want to find the smallest. We just go through everything and then find anything that's possible for me. So I don't need to go through this. I just need to say for K, right, in this, if st3k is larger than 0, right, and d3, for each one, right, for each one I need to choose which one to do, and d3 yeah, that's right. And I should say if d3 is smaller than math.inf, Then we go this. I will save this. Then tp temp -1 dot append something d3 plus this schmuck. All right, d3 plus this schmuck and st. Of course, we have to handle st first. So st equals st3. Copy st k shall -1, right? -1, and then we put it there. And that's all possibilities, and then we don't have to do any of this. Okay, and now we dp equals this. And once we're done, we are going at the last one. So what we need to do is go through every dp, right? Go through every one of them and find the smallest, which is just going to be for something in dp, okay? For, we can say G in dp as a group, right? Now for each group, we can say for D and this in G, right? And we need to find the minimum of D inside here, and for G and dp. So like this, then we pass. Oh my god. Oh, it's empty sequence. Wait, hold on. Empty sequence. We have an empty sequence. Nope, 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 no, 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 no. I thought that was a trick. Wait, hold up. How about we don't turn anything? Okay, so this is the problem? Zero. Huh? That doesn't make any sense. And now we have empty. We have something is empty. Too complicated. For G in dp, okay. For D, this in G. Res equals minimum res D. Return res. There we go. That is good. Okay, how about the rest? Okay. Was it taking too long, or? That looks suspicious. Okay, how about this one? Ooh. How about this one? Ooh. I think it's taking too long because I keep adding new things to it. I mean, it must be this thing just gets too big. Oh, I thought this one was shit. Too many states. Lord, how am I gonna do this then? Can't power it up. Yeah, a lot of those are not necessary. I'll take the hints. Well, it's for another day then. It's late. Man, this problem is hard. Oh, we already took the. We gotta take a look at the hints. I tried it at 1, maximize, but maximize didn't work. And now I have to power it up, but power it up also didn't work. Well, for one thing, I don't really have the copy. That's really not necessary, I think. Because I use it once and I just discard it. I don't know. I'm just throw something at this. See if it works. It is faster, but the answer is wrong. I do need to copy, but not all of them. if we take from temp j minus 1, I take this, I take this, and I take this, right? So when I go to the new one, I take this, I take this, and take this. So every time I take from the left, I need to copy it. But if every time I take from the top, I don't copy it, nah, it's not working. Crap. Yeah, this is useless. Okay, so a new idea is, but no, you have to copy because every single state from the top going to the bottom, we have this, right? All these states. Ooh, I can have duplicate states. I do have duplicate states. A set. Yeah, I see duplicate states. If I have a better way of dealing with the states, that would be much easier. I mean, we can set it, right? Really turn this into a set. Set of a set. Each one is going to be a set. All right, last push for today. A set. And dp0 is going to be a set math.inf, and this is going to be a set. Okay, this is going to be a set, and temp doesn't matter, is going to be a set. A set of, now this has to be set as well. Set of sets. Set of sets. Well, this should be a 10, a set, right? It's going to be a set. And then add a tuple, right, with this and this. st2 equals to list, turn into a list, this to this, and then add a tuple of this and this. tuple. Turn into a tuple. That's not a set. It's going to be a tuple. This is the same thing. Be list. A tuple of this. Turn into a tuple. Oh, still not working. Because you have to do this every single time. No. Is this what you want to write? Yeah, it's correct, but all right, that's been an hour. We'll have to, I'll give it one more shot. And if not, we're just gonna see the solution. I'll see you guys tonight. Adios.